Hi, good morning, all of you. So, in our previous class, we discussed about work done by the frictional force, and then kinetic energy, and then relation between kinetic energy and momentum, right? So, in today's class, I will introduce about the concept of conservative and non-conservative forces. So, conservative and non-conservative forces. So, do you know, can you say any examples for this conservative and first of all, what is the conservative forces? So, like simply I will ask a question here, like suppose if you're taking this a block, let it be a smooth inclined plane, let us consider, or let it be rough also you may consider here. Suppose a block of mass m is taken along this path here. So, suppose it is placed finally at this position here. So by applying some external force here, the block is displaced to this position here. So both this length I am taking as L and this height is H I am taking here. And so now the block is initially here. Suppose we need to place here. So then two possibilities are there here. That means you can pull the block along this inclined plane, or you can directly take from here and then you can lift directly vertically upwards here. That means both the ways you can lift that block there. That means you can pull along this path or you can lift along this path. Now our aim is to calculate the work done by this gravitational force, right? And so now the work done by the gravitational force along this path I am writing here, let it be W1. So then here we know when it is moving along this inclined path, then we can write this as mg sine theta, you may consider here. And this will be the force, but the displacement is along this direction. So both force and displacement are opposite each other. So what we can write there is force is mg sine theta, and mg cos theta is balanced by normal reaction, or I can say that there is no that means that mg cos theta component is perpendicular to the displacement, so that there is no work done there, right? So this mg sine theta into, and then what you can write there is L, displacement is L, and cos 180 now you can write. Is it clear? Because this mg sine theta and L are opposite each other, and therefore this is W1 is equal to what we can write there is mg L sine theta. Now we can write. So that is work done in placing this block from here to here. That means suppose say from bottom of inclined plane to top of inclined plane along this inclined plane. And now suppose if the block is displaced along this from vertically like this, from here to here, if you displace this block here, then work done what we can write there is work done is equal to W is equal to, now mg is acting vertically down here and displacement is h, which is upward. So what we can write there is mg into displacement is h, and again this cos 180 you can write, because this force and displacement are again opposite each other, and so their work done is W2 is equal to minus mgh you can write. Now here what I am saying is work done either along this path. Now this, can you say any relation between W1 and W2? Whether W1 is greater than W2 or W2 is greater than W1 or both are equal. So then you can say it as W1 is equal to, what we can write there is minus mg into h you can write. And because this L sine theta is nothing but you can write this as h by using this triangle, right? And so from that what we can conclude is there is W1 is equal to W2. W1 and W2 are both are numerically same, right? And so what we can conclude there is the work done by the gravitational force does not depend on the path followed, whether you are displacing the block along this direction or along this direction, or you may take any curved path like this, or you may displace along this path also. So it doesn't depend on the path what you are following there. It only depends on this initial and initial position and final position, it will depend. Or clearly what you can say is work done by the gravity means you can directly consider it as how much height it is rising. In case of gravitational force I am saying here, how much height it is rising you can consider there, or whether it is rising up or rising down, how much vertical distance it is traveling you need to consider there. And according to whether the height is, that means when it is moving upwards the work done will be negative, you will get work done by the gravity, and when it is moving down work done by the gravity you will get it as negative, irrespective of path followed, you can say like this. So whatever the path followed, the object is rising by a height of y, then work done by the gravity rising I am saying, so work done by the gravity is minus mgy, you can write whatever may be the path, whatever may be the conditions, whether it may be accelerating or moving with constant velocity, whatever the conditions are, work done by the gravity is given by that. And whereas if it is coming down, then mg y we need to write, because then it will be work done will be positive value there, right? So that is work done by the gravity here. It only depends on initial and final positions. And whereas if you calculate that friction, so now let us calculate the work done by the friction here. So now for the same inclined plane example, so let us take this body is moving upwards here. When it is moving upwards by using some external force, we are pulling it upwards. Then frictional force will be there in down the inclined plane, and that will be a kinetic friction since it is sliding. So when it is moving up, that means up the inclined plane. So then this work done, what we can write there is minus Fk into L, right? Where Fk value is nothing but we can write this as minus mu mg cos theta into L. And this minus already we are taking because the cos 180 we need to consider there. Force and displacement are opposite. Force is like this and displacement is up the inclined plane. So this is our work done here. So that is work done up the inclined plane is minus mu mgl cos theta you can write. Now whereas after reaching this inclined plane, now suppose again it is coming down for example now. So then it is coming down, then this frictional force will be there up the inclined plane, right? So then when it is moving down, let us write this work done here. When it is moving down, the work done by the friction we are writing. So that is mu mg cos theta, the frictional force value, into displacement L. Now what is the angle between force and displacement here? Still it is again 180 only, because now displacement is down and force is acting upward direction here. So the angle between them is 180 degrees. So 180 degrees, and so that this work done is again negative here. Minus mu mg L cos theta again you will get, right? So that means whether it is moving up or moving down, work done is same. And here you can say that this work done will depend on the path followed. If you are changing the path, then automatically this L value will changes, and so thereby this work done by the friction you will get some different value. If you are changing that path, then automatically that work done by the friction also changes there. And moreover, for the complete journey, if you consider, that means complete journey in the sense it is rising up and again coming down, work done by the friction is non-zero, right? So that means net work done, if you want to write, minus mu mgl cos theta into 2 we need to write, because we need to add these two values, work done up the inclined plane and work done down the inclined plane, so that it is non-zero value. But whereas work done for this journey, if I write net work done for this work done by the gravity, if you write like W1 moving up and W2 moving down, if you consider, or this net work done up and down if you add, that means up and down means for this, or you may take this as some values here. So like for while moving up, what we can write there is minus mgh, and while moving down, what we can write there is plus mgh, so that this net work done is 0, right? So that means for some forces you will get the situation like that, and for some forces you will get the situation like that. So for the closed loop also, closed loop means when body is taken back to its initial position, the work done is non-zero for some forces, and for some forces it is 0 like this. Is it clear? So there are two types of such a different forces are there. So now this type of force we call it as conservative force, and that type of force we call it as non-conservative force. So the conservative force means what we can say simply this: if the work done by the force is independent of the path followed, and if the closed loop, for the closed loop, if work done is 0, closed loop in the sense if it again body reaches to the initial position, so that work done is 0, then we say that it is a conservative force. And so for that conservative force, work done is independent of the path followed. It only depends on initial and final positions, right? So such a force is nothing but conservative force. And as we discussed here, we can say this gravitational force is one of such a conservative force here. And the other conservative forces will be there like elastic force, like spring force, and then we can also say like electrostatic force. That electrostatic force we will discuss in second year. in electrostatics topic. So electrostatic force. So that is another conservative force there. And this non-conservative force means which depends on the path followed. If the work done by a force depends on the path followed, or for the closed loop if the work done is non-zero, that means again if body comes back to its initial position if work done is non-zero, then such a force is said to be non-conservative force here, right? So for conservative force, even if you are coming back along other path, work done will be zero only. Work done for the closed loop. It doesn't mean that we are moving up and moving down like this. You may travel like this and it may come here. You may follow while return journey. You may follow any position. Closed loop in the sense just you need to reach the initial point. Once if you reach the initial point, then work done will be zero for conservative forces and it is non-zero for this non-conservative forces here. An example for this non-conservative forces you can observe here friction, and another example you can say like viscous force or air resistance. So that viscous force, about the viscous force, another topic is there for us, viscosity. So in that we will discuss in detail about that viscous force, right? So just to mention about that conservative force. First again keep that subheading conservative force. If work done by a force, if work done by a force for a closed loop, for a closed loop in the sense that is the meaning here, a body again reaches to initial point. For the closed loop is 0, for closed loop is 0, then it is said to be a conservative force. Then it is said to be a conservative force. Next, in that only mention that work done by the conservative force, work done by the conservative force is independent of path followed, is independent of path followed. It only depends on initial and final positions. It only depends on initial and final positions. Next, you may mention that example: gravitational force, spring force in bracket elastic force, spring force in brackets elastic force, and then electrostatic force, or conservative forces are examples for conservative forces. And now therefore finally mention about this work done by this gravitational force. So whenever gravitational force is there, this is a simple technique what you need to follow. So whatever the path it is following, how much vertically it is rising, you need to consider there. So with that directly you can substitute the work done calculations easily. Work done by the gravitational force easily. Is it clear? So I am not mentioning it as a special point. You need to remember that. Next, write this non-conservative forces. Whether it is positive or negative means work done by the gravitational force. Simply you need to observe whether it is moving up or moving down. When it is moving up, work done is negative. When it is moving down, work done by the gravitational force is positive. Right? So right. Next, non-conservative forces. If work done by a force for a closed loop, if work done by a force for a closed loop is non-zero, then it is said to be a non-conservative force. Then it is said to be a non-conservative force. Next point, work done by a non-conservative force, work done by a non-conservative force depends on the path followed, depends on the path followed. Example: friction, viscous force. friction, viscous force, etc. Right? And so now sometimes they will give some force and they will ask whether it is a conservative force or non-conservative forces. So that means then you need to consider a closed loop and you need to calculate work done along that closed loop you need to calculate, or we can use for verification we can use another method which I can say that del operator, by using some del operator, or simply you can try to calculate the work done there. So if any force is given for you and if they are asking whether it is a conservative or non-conservative force, so try to calculate that work done with the help of that given force. Suppose if you are getting if you are getting the work done calculation without any requirement of relation between x and y, then that force is said to be a conservative force, because relation between x and y is not required, in the sense path followed is not required for us. So then you can say that such a force as a conservative force, right? But whereas for completing that integration or for completing the calculation of work done, if you need the relation between x and y or z, then it is said to be a non-conservative force, because it needs the relation between xy and z, means it depends on the path followed, right? For that particular path, whatever the relation you are taking, if you are taking x is equal to y, you will get one value of work done. If you are taking like x is equal to y square or y is equal to x square, you will get another relation, another value of work done. So for different paths, you will get the different work done there. So like that, simply just by starting the calculation of work done, you can decide whether it is a conservative force or non-conservative force. Is it clear what I am saying? So and another del operator is there. So let us I will explain by del operator also. By using that operator, you can write whether it is conservative or non-conservative force. So just to mention that to verify whether the given force is a conservative force or non-conservative force, we need to calculate work done by the given force, from initial position to final position, from initial position to final position. To calculate work done, to calculate this work done, if relation between x and y, in brackets path followed, that relation is nothing but our path followed only. Path followed is required. Then the given force is non-conservative. And if a relation between x and y is not required, then it is conservative. Then it is a conservative force, right? So it is one method. So now let us verify that method here. So simply what I am saying, there is suppose say there is a force Fr is equal to minus k into y I cap plus x j cap, right? Suppose I am taking this force here. The particle is initially at 0, 0. So first it is displaced from this position to a, 0, and then it is displaced to a, a. So that is our condition here. Just you may mention example, a force F bar is equal to minus k into y I cap plus x j cap, displaces a particle from 0, 0 to a, 0 and then to a, a. And now I am calculating the work done here. So now our aim is to find, our aim is not to find the work done. Our aim is to find whether this force is a conservative force or not, right? And so now what I said that above matter is nothing but simply we need to calculate this work done by this force here. So like let us write this F bar dot dr bar integral of, and so now I am calculating this work done here. So minus F is nothing but like y I cap plus x j cap dot dx I cap plus dy j cap, right? So this is our condition here. That means you may consider the z component also, because here x and y is only there. So we know already, we discussed already this, right? So then z component is not required here if it is x and y only there. So then what we can write there is y into dx plus x into dy. Is it clear? That means after dot product I am writing here y into dx and x into dy. Now what I am saying is, to complete this integration, or now to find the work done, that means to complete this work done, to complete this integration, if you need the relation between x and y, then it is a non-conservative force, because we need the relation between x and y means for different x and y relation you will get the different values of work done. That indicates it is a path dependent, so it is a non-conservative force. If the relation between x and y is not required to complete this integration, then it is a conservative force, right? So that means what I can write there is, now for this is it required to complete this integration. So what you can write there is integral of d of xy. So that means now for this relation between x and y is not required to complete this integration here, right? And so that this work done, now we can write there is k a square, now we can write there. So that means this from this what we can conclude there is, the given force is a conservative force, you can write here, right? So this is a conservative force. And then mention that another method, there is another method to verify this. This is the one way of verification here. Just we can find this work done. If relation between x and y is required to complete the work done, then it is said to be conservative or non-conservative. If it is not required, then it is said to be conservative forces. And next, so second method, just mention that the given force, whether it is conservative or non-conservative, can be verified with the help of curl, with the help of del operator, This del operator is nothing but differential operator. So that is nothing but like this. Now we need to write here del bar cross. That means first let us write the meaning of this del bar. Actually about this del bar you will get in engineering mathematics, you will get that. In physics also you will use that. So that means the del operator is nothing but it's a differential operator. So it can be written as like dou by dou x of I cap plus dou by dou y of j cap plus dou by dou z of k cap. So this is the meaning of this del operator here. So now with the help of this del bar also, now we can calculate this. And just it is that means why you are representing it as a del operator means in mathematics, in engineering mathematics you will get that. Engineering mathematics and physics you will get more about that. Just we are I am taking it as another method to verify that, and next I will explain how to verify that. That means now here the given force is a conservative force if del bar cross F bar is equal to 0. So just you mention that. So after writing this, so where del bar is given by this we call it as a del bar. The given force will be a conservative force. The given force will be conservative force if del bar cross F bar is equal to 0. That means cross product of this del operator and then F bar is 0, then it is said to be conservative. If it is non-zero, then it is a non-conservative force, right? And so now this is simply, it is nothing but del bar cross F bar is equal to, what we can write there is, just we know how to find this value here. Like suppose this is I cap, j cap and k cap. Del operator I am writing here dou by dou x, and this is dou by dou y, dou by dou z. And suppose f value I am taking in terms of these components here, fx, fy and fz. Let us take that three components there, right? And so now let us write this. So del bar cross f bar means what we can write there is I cap cross, so I cap into, so then this value it can be written as df z by dy minus dfy by dou fy by dou z minus j cap into, so this is dou fz by dou x minus dou fx by dou z plus k cap into, now again the remaining terms like dou fy by dou x minus dou fx by dou y. So right, so this value is to be 0 for this conservative force. The force is to be conservative means this value is to be 0. So this value is to be 0 means you can say that each component or each coefficient should be equal to 0. I cap, j cap and k cap value should be equal to 0. That means for conservative force, del bar cross f bar should be equal to 0. So that implies what we can write there is, so that means each component should be equal to 0 there. So I am writing from that in order I am writing there, so that I can write this as so dou fx by dou y minus dou fy by, next dou fx by dou z minus dou fz by dou x should be equal to 0. Next dou fy by dou z minus dou fz by dou y is equal to 0. That means each coefficient, just I am taking in order, other than that there is no any change here. That means I cap coefficient should be 0, j cap coefficient should be 0 and k cap coefficient should be 0. That means if these values are 0 or these values are verified, then you can say that given force is a conservative force, right? So like that you can verify there. That means generally this method will be easy when only the two components are there. That means if you are not getting any idea by using our previous method, try to follow our previous method only, work done calculation, just to proceed, whether even though work done is not required or work done is not asked in the question, to answer whether it is a conservative force or non-conservative force, you need to verify like that. Just by integration to find the work done, we integrate that, and if a relation between x and y is not required, you can say it is a conservative. So otherwise this is another method. If you are getting confusion in that, you may follow this method there to find whether it is a conservative or non-conservative. For example, the previous one you can also verify this. That means previously what we consider there is our force is like f bar is equal to minus of k of I cap, sorry, y I cap plus x j cap, right? So k is a constant, you can take it out, and because it is a constant, it has no importance in this. So first I am verifying this here. So then this is dou by dou y of fx. Now here fx is nothing but y minus dou by dou x of fy is nothing but x. So now let us find this value here. So then this differentiation of y with respect to y means 1 and minus x with respect to x means 1. So this is 0, right? So that is verified. And here to verify this, z component is not there. So no need of verifying this. So just by verifying this itself, now you can conclude that, because z component is not there in that. Is it clear? So like that, now we can conclude that that force is a conservative force, because we are getting that value as 0 there, right? And so that like that you can verify there, whether you can verify by work done or by using this. Or so I am saying prefer that work done method. If you are not getting, or if you are getting any confusion in that work done method, you may go by this del operator method there, right, to verify that whether that given force is a conservative force or non-conservative force. Just write this a problem based on this. The force acting on a particle is given by F bar is equal to 2y square I cap plus x square j cap newtons. The particle is initially at origin and displaced to the point 5 meters comma 5 meters, displaced to the point 5 meters comma 5 meters. So that means this is shown here, this diagram. This is O, A, B I am taking there, right? So that this A is 5 comma 0 and this B is like 0 comma 5. Find work done by the force. When it is particle is taken along. When particle is taken along A, O, C. This point is C. When particle is taken along A, O, C. That is first question. And second question, when the particle is taken along, first one is OAC. Second one is when particle is taken along OBC. And the next one is when the particle is taken along OC. And also conclude whether the given force is conservative force or a non-conservative force. Whether the given force is conservative force or non-conservative force. And so now work done is required here. So work done, so along the different paths already I asked there. So if you are calculating work done along different paths and if they are equal, then you can say it is a conservative force, and if there it is non-equal, then you can say it as a non-conservative force. So work done along for one path I will explain, the remaining you can solve there, right? So then along OAC path I will explain here. So that means work done along OAC. So in that first let us calculate work done along OA. So work done along OA I am calculating there. So OA means it is along x direction. So what I can write there is the integral of f bar dot dx I cap I can write, because y cap term will be 0, dx y cap is 0 or dy value is 0. And so now let us write this f bar value for this path here, OA path. So for this OA path, what I can write there is this y is equal to 0 here, right? So this term is 0. So that is the thing you need to observe here. So 0 I cap plus x square j cap dot dx I cap. Is it clear how to write? So for this OA path, x value is, y value is 0. So I am substituting that 0. And x value will be there, that is a variable term, so that I am substituting there. And so now here x value varies from 0 to 5, and therefore integral of x square dx from 0 to 5. So that is x cube by 3. So you can write this as 125 by 3 joules. So that is OA path. Is it clear? And next let us calculate A to C. Work done along AC. So now work done along AC in a similar way. So then F bar dot dr bar let us write here. Now the dr bar you can take this again dy j cap you can consider there, because now the displacement is only along y axis, x displacement is 0 there, right? And so therefore now F bar substitution, let us see the F bar value for this. So now for AC path, which value will be constant here? X value will be constant here. X value is 5 only. So you can substitute directly x is equal to 5 here. Is it clear? X is not variable. So for this AC path, x is a constant value, only y is variable. So what I can write there is f value instead of f value. You can write this as now 2y square plus 2y square I cap plus 5 square j cap dot dy j cap. So then this is our work done along this AC value here. Now do the dot product there. So then here I cap dot j cap, so that is 0, so that y component term will become 0, and so then only this j cap dot j cap will be there, so which is integral of 25 into dy, right? And so now this dy value, y value varies from 0 to 5, so that again this is 25 into 5 you will get, so which is along this AC path is 125 joules. Therefore, work done along OAC path will be equal to work done along OA plus work done along AC. So, which is 125 by 3 plus 125. So, right. So, this can be written as 500 by 3 joules, right? 375 plus 125, 500 by 3 joules. So this work done along this OAC. Now similarly do the calculation for this work done along AB, OB and BC, and work done along this. So along this, in calculating along this AC path, then you will get the clarity about that, so that you can say conservative or non-conservative directly by verifying for this path here. Just I will explain OC path here. Let us see this. So this path you need to calculate, OBC you need to calculate, right? So now let us calculate along this OC. I am explaining here because here some substitution is required there, so that this is F bar dot dr bar. Now here when the body is traveling along x and y, you need to observe that when the body is traveling along OC path, both are variables here. That means both x value is variable and y value is variable, so that I am taking it as dr bar. Now previously I took like only dx and dy there, because only that component is changing, so that I took directly like that. So but here both x and y are changing, so I am taking it as dr. And so now this value, now I can write this as the integral of f bar. So f bar means now we need to write like 2y square I cap plus x square j cap dot dx I cap plus dy j cap, and therefore this value I can write this as 2 into directly I am doing the dot product here, that means you can write this as integral of y square into dx plus x square into dy after doing this dot product. Now here from this you can conclude whether it is a conservative or non-conservative actually here. Now to complete this this integration, this is the thing what I said previously there. So to complete this integration, the relation between x and y is required, right? So without the relation between x and y, you can't integrate this. You can't complete this integration here. So the relation between x and y is required to complete this integration. So then to complete this integration, so here we can integrate this calculation only if relation between x and y is required there. So from that you can conclude that this given force is a conservative force, non-conservative force you can conclude here. Now in this example, to find this work done along OC, now the relation is known to us. So according to the given values, you can say that it is a 45 degrees here. So that 45 degrees means now I can write this as x is equal to y, you can substitute there. So with the help of that x is equal to y, you can complete this integration here. So that means this value I can write this as 2 into x square dx plus y square dy, you can write. So is it clear why I am writing this? Since that x is equal to y, x is equal to y for AC. For this path, x and y are equal, or y is equal to x, that is nothing but that equation. So that now you can replace this x and y correspondingly there. So that now you can complete this integration here. Is it clear? So now, therefore, now we can conclude that this work done will be, that means this force will be a non-conservative force, you can conclude here. So like that, you need to verify this conservative or non-conservative forces there. Then complete that integration. Then according to our conclusion, you should get the different values of this work done along these different paths there, right? And I will give some other forces. So do that calculations also there. So now note down some other forces and verify whether they are conservative forces or non-conservative forces. Like F bar is equal to yx square I cap plus x square j cap. F bar is equal to 2xy I cap plus y square, this is 2xy I cap plus two y x square, 2yx. Uh, 2y, let us write this as xy square, right? Xy square j cap. So let us take this as another force. And if suppose another force I am giving like some k by r square into r cap, where r is the position vector. So if x and y is are given, then you can do like this. When r is given, then how to solve this? You can do the integration directly in terms of this r here. So like f, you can substitute here f bar as the given expression, and the dr bar means then you can substitute it as dx value, you can replace it as dr. So then you can do that integration there. Like what I am saying is f bar dot dr bar, you can write. Now this f bar means you can substitute this given force there. So just by substituting that given force, you can do that integration there, right? So like that, you can do that calculations there when r as a function of r is given. So now verify whether these forces are conservative force or non-conservative force, and you may cross check your calculations by either by taking this work done calculations. That means by suppose if you are doing by this work done method, if you are getting the non-conservative force, and cross check by using our del operator also. So by using del operator also, suppose for this if you are getting it as a non-conservative force, for example, by work done calculation, and so then cross check it by using this del operator also, so that you will get the clarity about that. And actually like potential energy, now we need to introduce here. So that potential energy is nothing but actually it is energy possessed by position or its configuration or its state generally we define. So before that, what you need to learn is potential energy is defined only for the conservative field or conservative force, right? So just mention about the definition, and more detail I will explain it our next class. Potential energy. So generally we represent with that U. So write that. First mention that potential energy is defined. Potential energy is defined only for conservative force. Only for conservative force. That means whenever you are defining potential energy, that force will be a conservative force. So like you can define the gravitational potential energy. Gravitational potential energy is a gravitational force is a conservative force, we know. And we mentioned elastic force or the spring force. So for spring potential energy we can define, and in electrostatics we will define the electrostatic potential energy like that. So for friction you can't define the potential energy there, because friction is the non-conservative force, right? So generally in our lower classes, potential energy definition means we mention like energy possessed by the body by the virtue of its position, state or configuration. So here we will define it in a different way. So you may mention that definition also. So potential energy can be defined as energy possessed by a body by the virtue of its position, configuration, or state. And next mention that means in our intermediate level we need to use this following definition here. So actually this potential energy, before defining this potential energy we define the change in potential energy there. So just mention about that. Change in potential energy is equals to the negative of work done by the conservative force. Negative of work done by the conservative force. WC means conservative force, work done by the conservative force. So this is a basic relation between potential energy and this work done, or this is the basic definition of this potential energy here. So that means you need to use this calculation here. Change in potential energy is equal to the negative of work done by this conservative force. You may integrate this equation here. So if you are integrating this, minus integral of dwc you can write here, right? And so now this value you can define this as some u initial to u final, and so that this is from initial to final you can define there, or initial position to final position. So that this value what we can write there is u final minus u initial is equal to this negative of f bar dot dr bar. This is f conservative here. Fc means conservative. R initial to R final. So this gives us total work done by this conservative force actually here. So this is nothing but minus of WC you can write. Work done by this conservative, total work done or net work done by the conservative force. Now we can answer here. So in general, while defining this potential energy, so this is an important relation here. So this is important relation what we can mention there here. So that means change in potential energy is equal to negative of work done by this. So final potential energy minus initial potential energy. Therefore what we can write there is final potential energy minus initial potential energy is equal to, this is our delta U, negative of work done by this conservative force. So this is delta U is equal to minus WC you can write. So that means delta U means that is nothing but you need to remember this one also. So mention like this, delta U is nothing but final potential energy minus initial potential energy there, always delta U means. So that final potential energy minus initial potential energy will be equal to negative of work done by the conservative force, right? So that relation you need to use here. So in when you are calculating this, actually when you are deriving an expression for the gravitational potential energy or elastic potential energy or any electrostatic potential energy, we take initial any one of them as a reference. For example, if you are taking that initial potential energy as a reference at infinite distance, if you consider here. So next mention that here after this, to define absolute potential energy, absolute potential energy means potential energy at any point. Here just we are calculating, actually we can define this change in potential energy here, what we are writing these calculations are. If you want to define potential energy for a particular point, then we need to write this absolute potential energy now we need to write. So to write this absolute potential energy, we need to take some reference there. So just mention that to define absolute potential energy at any point, to define absolute potential energy at any point, we need to take some reference. We need to take some reference, which is generally taken as infinity, where potential energy is 0, where potential energy is 0, right? That means R initially is taken to be infinite, so that this U initially is equal to 0 there. So under that condition, then this final potential energy minus this initial potential energy 0 is equal to integral of Fc bar dot dr bar from infinity to R, you can write there. So that means up to that R position there. Therefore this potential energy is equal to minus Fc bar dot dr bar. This U final I am writing it as U here. So now this gives a potential energy at a distance r from this our reference point there. So this is a way of defining this potential energy at a particular point there, right? But now as of in this topic, we don't use these definitions here, just we use this basic relation here. And that means we don't use this integration calculations and all this. So just we use this this definition here. Change in potential energy is equal to our negative of work done by the conservative force we need to use, right? So this integration calculation we will use from our gravitation topic onwards, like in gravitation and in next in second year electrostatics, and we will discuss more about this calculation here, and we will calculate how to approach this, how to find this potential energy for a particular position R. So in this it is not required for us. So just it is sufficient to remember this one. So change in potential energy is equal to negative of work done by the conservative force, that is sufficient there. And based on this, we need to write the gravitational potential energy and electrostatic potential energy, and we need to write those and elastic potential energy there. As electrostatic potential energy is not required in this 11th class, so leave that one and we will discuss in electrostatics. So here we will discuss only like gravitational potential energy and spring potential energy there, right? So then that I will describe the formula for those gravitational and electrostatic potential energy in our next class, right? Thank you.